let's look at the scenario. We've got the NBA prior to the 1999-2000 season. The NBA decided to make some rule changes to increase their scoring, make it a more exciting game, exciting product. So their data from before the season had the average points scored per game to be 183.2. So this is the combination of both teams. And they collected some data, and we have it in a spreadsheet for 25 games. And they want to use this data to determine if these rules actually helped increase the scoring, or if we have a statistical anomaly. So we want to first write down what would our null and alternative hypothesis be for this scenario. So before we do that, let's get some notation down. So I'm going to let mu denote the average number of points scored per game in the season, 1999 to 2000. So just as a quick note, mu is the population parameter. So this is what we're testing. We're testing something about our population. We have some sample data that we're going to look at. So when we write down let's write down first our null hypothesis. Our null hypothesis is always about the population. So we're testing something about mu, and this always has to be equal. We always assume something is true for the null hypothesis. So we're going to assume that our population is equal to 183.2. So we're assuming that there has been no change in the points scored per game. And our alternative hypothesis, we're checking the league NBA wants to know if their rule changes increase scoring. So for our alternative hypothesis, we're going to say that our average points scored per game is greater than 183.2. So just as a quick summary, we always test with an hypothesis our population parameter, whether it be mean, max, median, whatnot. We're testing the mean, population mean in this case, and our alternative always has to be equal. All right, and as importantly, or maybe more importantly than writing these down in mathematical notation, is we write this out in English. So we assume the average number of points scored per game in the season is 183.2. So we're assuming this to be true for the null hypothesis. So I always have to assume something is true for the null hypothesis, and the alternative is that scoring has increased. So there we have our null hypothesis and alternative hypothesis, both in mathematical notation and in fairly simple English.